Hi all, welcome to Kotai channel. Let's take a look at the house price prediction machine learning model which we are going to build from scratch in this video. So here is the final project looks like Bangalore house prices predictor, and here we have list of the locations. Let's choose Whitefield, and total square feet will be 2000 square feet, and number of bedrooms 3, number of bathrooms 3, and number of balconies 2. Let's predict the price. So the price of the house is 148 lakhs. What if I change just the location? If I change the location from Whitefield to Electronic City, so the price has been changed to 149 lakhs now. Let me increase the total square feet to 2200 here instead of 2000. If you see here, the price of the house has been changed from 148 lakhs to 149 lakhs to 171 lakhs. So this is how our Bangalore house price predictor machine learning model works. So it takes the 5 inputs. One is the location, and another one is the total square feet, and number of bedrooms, number of bathrooms, and number of balconies. Then it will predict the price. First things first, we are going to build linear regression machine learning model to predict the house prices. For this, we would need the Bangalore house prices across different areas. So once we have the data set, we have to do the data analysis, and then we have to do the pre-processing of the data. So once the data cleanup is done, we have to split the data set into two parts. One is the training data set. 80% of the data set will become the training data set, and 20% of the data will become test data set. So once our data split is done, we will be creating a linear regression model here. So once we create the linear regression model, we have to train the linear regression model with the training data set. So once our model is trained, then we will be evaluating our model with the test data set. So once training and testing is done, our model is ready to predict the house prices now. Now we will do some kind of testing with the random numbers to see how our model is predicting the house prices. So once we are done with all this process, we have to deploy finally it as a web application, as you guys have seen in the earlier part of the video. Required tools for developing this machine learning model. One is NumPy, and second one is Pandas, third one is the scikit-learn. Let's dive into the coding. Here I have created a house price prediction project folder. Here we have the source dataset as well. Let's open the Jupyter Lab. So our Jupyter Lab is up and running. Let me create a new notebook, rename notebook, house price prediction. Okay. Now we would need the libraries, right? So if you want to install Python libraries, open command prompt in your laptop or system. Just type in pip install pandas, numpy, and scikit-learn. I already have these libraries installed in my system, so I'm not installing them here. So if you're running it for the first time, please do install these necessary libraries. So once the installation is done, let's import those libraries. So we have imported the libraries. Now let's import the dataset. Data is equals to pd.read_csv of. Here is our source dataset. So just let me copy the path, paste it here. So now we have imported our data. Let's see how the data looks like. I'm just printing the first top 5 rows. If you see here we have a couple of columns. So first one is area type, and another one is availability. So area type denotes here the super built up area, plot area, built up area, super built up area. There are a couple of options are here based upon the area type. And next one is availability. So when that particular flat is or house is available, few of them are ready to move, so which are ready already done with the construction, so we have to directly move into the flat or house. So few of them are given the month and years as well. Now another one is the location where this particular house is residing in, and next one is size, so whether it is a 2-bedroom or 4-bedroom or 5-bedroom. And next one is society, so the gated community name as well here. and total square feet. So what is the length of that particular flat or house, and the number of bathrooms and the number of balconies. Finally the price. So price here is in lakhs. Okay, now let's check how many rows of data is there. Okay, just removing this one, shift enter. If you see here, it is having 13,320 rows with the 9 columns. So now let's do the data cleanup process. First, analyze what are the required columns for us to predict the price of the flat or house. Okay, and here if you see here, area type is, I don't think it would make much difference here, so I'm going to remove this area type. And the next one is also availability, also I will be removing them here, and society. So I'm going to drop these 3 columns, area type, availability and society, which are not going to make much sense. Okay, so data drop of columns is equals to area type and availability and finally society. Okay, so let me do one thing here. In place is equals to 2. So I wanted to apply same thing on the, I wanted this operation to be applied on the same data set. So it's done. Now let me type data. So now here we have location, size, society is still there. Sorry, I just did typo here. Let me recopy here, paste it here. Okay, it's not having. Let me run from starting. It's there now. Yeah, so now we have only 6 columns. So we have dropped the 3 columns, right? Out of 9 we have dropped 3 columns. So now we are left with the 3 columns: location, size, total square feet, bathrooms, and number of balconies, and then price. So now what I'm going to do here is, let me drop the, if there are any null values. Okay, drop any. Here I'm going to drop the null rows and missing values, so this won't be affecting the our machine learning model. Okay, now drop any in place is equals to true. Now again data. So now we have been reduced to 12,710 rows. So it was around 13k, so now it has been reduced to 12k. So we had the missing values and null values. So now we are done with the data cleanup. Now we are done with the data cleanup activities. Now let's see the distinct values for each and every column. Data dot location dot unique. Let me do one thing here. Value counts. I'll take value counts. So if you see here, so Whitefield is having 514 rows. Okay, and Sarjapur Road is having 372, Electronic City 300, and 261, 231. If you see here in the bottom, so this couple of locations which are having only one entry. Okay, so this makes the location field is very imbalanced. If you feed this kind of data into our machine learning model, it may not give this accurate results. So what I'm going to do is, we have to do the data balance. So what I'm going to do here is, instead of having, let's find out how many locations we're having less than 10 entries. Okay, for that one, what we are going to do is, data location stats is equals to data of dot group by, we have to do the group array, and location dot, and we have to take the count, aggregation and count. Let me print this location counts, location stats. So now we have 1265 rows for each and every location that is having a one entry. If you see here 116. So let me sort these numbers. Okay, sort values, ascending equals to false. Okay, now we have sorted this data set, right? Now what I am going to do is, let's see how many locations are having less than 10 entries. Okay, locations less than 10 entries. Step less than or equals to 10. Now let me print this. Now if you see here, 1028 locations are having less than 10 entries. And I have observed one more thing here. If you see here, the data, there is a leading spaces are there as well here, okay, in the data set. So we have to remove them first. So what I'm going to do is a data of location is equals to data of location dot, and let me do one thing. Let me copy this cell into the top. Okay, here data of location dot apply. I'm going to apply lambda function here. So lambda function in Python will be enabling, we can write the function in a single line. Okay, x dot strip. So it will remove the spaces in the starting or ending of the string. Okay, and I'm applying it here. So after applying, just going to just check the data dot location dot value counts. So if you see here, before we are stripping this spaces, earlier the number of unique locations are 1265. Now it has been reduced to 1254. Okay, now what I'm going to do is I'm doing the group by, and I'm taking the locations which are entries are having less than 10 times, just taking them, and I'm just running this one again. So now we have 1017 entries are having the less than 10 entries, okay, in the data set. What I'm going to do is, wherever this location entries are less than or equals to 10, I'm going to replace that location is equals to others, okay, to make our data set more balanced. Okay, let me do that. Data of location is equals to data of location dot apply. So what I'm going to do here is, I'm going to write a lambda function. Here in this data set, we are having the where the location is having count is less than 10. So whatever the location which is part of this location entries, this data set, I'm going to make it as a other. Okay, lambda x, make it as other if x in this particular data set entry, else as it is the same location will be there. Okay, data of location dot apply. I'm writing a lambda function here. So wherever the location entry is less than 10, I'm making it as other location, otherwise it will be the same location. Shift press enter, it's done. Now let me type data of location dot value counts. If you see here, other locations are having 2739 locations are having others now. Now if you see here, 2739 rows are having the location as other, and remaining locations are there now. Okay, if you see here, the minimum number of entries for particular location is 11 now. Okay, now we are done with the cleanup activity of location dataset. Sorry, location column. Now let me print the data here. So location cleanup is done for this particular column. Now let's check for the size. Data dot size of let me have here. Let me write it here. Okay, data of size dot unique. So here it is printing the unique values for the size. If you see here, 2 BHK, 4 bedroom, 3 BHK, 3 bedroom, 1 BHK, 1 RK, there are different kinds of values are there. Okay, it is not following a proper terminology. Either it is not BHK, either it is not bedroom. Okay, so now what I'm going to do is, I'm going to split this data set Okay, if you see here, here it is having 2 bhk. Okay, for every numeric value there is a space, and then they have mentioned whether it is a bhk or bedroom or rk. So what I'm going to do is I'm going to split this data set and I'll only take this numeric values. Okay, I'm going to create a new column called bedrooms is equals to data of size dot apply. Again I'm writing a lambda function here, lambda function x dot strip. So I'm stripping the data set here based upon a space. Okay, not strip, it should be split. Okay, I'm splitting the string based upon the space. Okay, so I'm just going to take the first value in that split, right? After splitting I'm just taking the first value, so I'm mentioning it as 0 and I'm converting this into integer. Okay, incomplete input. Okay, now it's done. Let me print the data now. Okay, now if you see here, I have the bedrooms column, new column, which is having only the numeric values, so I don't have to rely upon this size column now. So the cleanup activity is done for the location column and size column is done. Now let's check what are the unique values are there in the total square feet column. Okay, data dot total underscore square feet dot unique. If you see here carefully, the square feet of the flat or house is mentioned in between the range from 1133 feet to 1384. So this kind of data again we have to do the cleanup here. So what I am going to do here is, let's take the average of these two numbers. Okay, if you take 1133, so it will be a lower number, right? And if I take the 1384, it will be a higher value. So instead of taking lower value or either higher value, what we are going to do is we are going to take the average of these two numbers. Okay, let's write a function to do that. Okay, definition clean square feet. So what we are going to do is, if I look at here carefully, so these are the two numeric values and there is a hyphen is there. If you see here carefully, so these are two numeric values and these two numeric values are separated by a hyphen. So we have to split the string with the hyphen, then we have to do the aggregation of those two numbers. Okay, now what I'm going to do here is, let's collect the tokens of square feet dot split, splitting this with hyphen. Okay, if this tokens is to length of these tokens equals to 2. So what I am going to do here is, if it is having two numbers, I have to do the aggregation, right? Return float of tokens of 0, first one, plus float of tokens of 1. So first value and second value I'm taking, I'm doing the summation of these two numbers and I'm dividing it with the 2. Okay, I'm just taking the average here. If there is only one value, then what I'm going to do is, yeah, else try. If it is having only one value, I'm just taking that particular value itself, whatever the input value, square feet float of. If it is not a numeric value, then what I'm going to do is return none. So we are done with the function. Let's see how this function works. Okay, let me call clean. If I pass 200, it is giving me 200.0, so it is converting into the float value. What if I give 100-200? Okay, see, it is giving the average of these two numbers. Okay, suppose if I have some string value, okay, it will return none. So that's what we have mentioned, right? Here if it is not satisfying either of these two conditions, then it will be returning none. Okay, so I'm just removing these cells, and so what I'm going to do is apply this function to total square feet column here. Okay, So data of total SFT is equals to SFT, right? It's the column name SQF2 SQFT, and data of now what I'm going to do is I'm going to apply this function clean. It's done, it's applied. Now let's print data dot total SQFT dot unique. Let me change it here. Oh, my bad, I'm just typing it wrong. If you see it has been converted to the float numbers. So now we are done with this one as well. We have completed the data cleanup for the location column, size column, total square feet. Now we are left with the bathrooms. It is there, so we can't do anything. It is a numeric value. And next balcony is there. Next price is there. So what I'm going to do is data dot describe. So it will describe the whatever the numeric fields are there in our data set. So total square feet is this one. So total 12,668 entries are there. If you see here, total square feet is having the less number of entries when compared to the bathroom, balcony, price and bedrooms, because we have written with none, right? So there are some unwanted numbers are there, so we have to do the cleanup activity, that one as well. So we have to remove those missing values from the data set. Okay, let's do that first. Data dot drop NAF in place is equals to 2. So I'm done. Now data. So now the data set is reduced to 12,668 rows. So cleanup activities for completed for the location, size, total square feet, bathrooms, balcony, price and bedrooms is there. Data dot describe. So if you see here, so all these are entries are having the data now, and this is the mean value, this is the standard value, minimum, max 25%, 50%, 1640, and here it is maximum of 52,272. That is the maximum value, and there is one which is having 40 bathrooms and 3 balconies are there. So price is 2912, and the bedrooms are 43 bedrooms are there. So this is how the numeric values looks like. So we have the bedrooms and we have the total square feet. I'm going to divide this total square feet with the number of bedrooms, so that would give me the what exactly the how much square feet per each bedroom is having. Okay, why I'm doing this, I'll explain you. Okay, I will show you the data of let's create a column called square feet per bedroom, square feet per bedroom. Okay, data of total square feet, right? Okay, divided by data of bedrooms. So we have created data is there. We have created a new column called square feet per bed. Okay, per bed dot describe. So if you observe carefully here, the minimum value of in this describe method for square feet per bedroom column is saying that 0.71 feet per bedroom. It looks like an invalid data to me. So now let's apply a filter condition on square feet per bedroom column, where that minimum value of square feet per bedroom should be greater than 300 feet. Okay, we will consider only those kind of data set only. Okay, let's apply that now. data. Let's create a new data frame. The data square feet per bed greater than or equals to 300. So at least a minimum bedroom should have a 300 square feet. Okay, now this data set is ready. Let's check it out. So our dataset count has been reduced to 12,030. Okay, so with the 8 columns we have added 2 extra columns. One is bedrooms and one is square feet per bedroom. Okay, now we have done with the total square feet. Bathrooms is done, balcony is done, now price is there. Let's create one more column which is called the square feet per price. Okay, and data of square feet per price per square feet, price per square feet equals to, so what we are going to do is we are going to divide this price, just multiplying it with the, it is lakhs, right, with the lakhs, divided by total square feet. Okay, so now we have data 2, sorry, right here. Okay, data 2. So here is the data 2 which is having the price per square feet. Let's apply the rounding function as well here. Round of 2 digits. Okay, now this is the price per square feet. So let's describe this price per square feet. Okay, price per SQFT. Done. Describe. Okay, so the minimum value is 267 rupees per feet. Even this is also looks like an outlier for me, so let's remove that value as well over here. Let's take a minimum value of at least 2000 rupees per square feet, so that at least looks like even if it is an outskirts of the city also, that may be judgeable. Okay, and what I'm going to do is data 2 dot, let's get another data set, data 3 dot, data 2, in data 2 what it is, price per square feet column equals to greater than at least 2000 rupees, greater than or equals to. Okay, data 3. So here is the final data set. Okay, with 11,985. We started around 13k, now it has been reduced to 11.9k. So now data cleanup is done. So now we have to identify what are the columns that we are going to feed it to the model. Okay, I just wanted to drop couple of columns. Size, it is duplicated, we don't need that because bedrooms is already there. Let's have total square feet, and bathroom should be there, balcony should be there. Price should not be part of this one, so we have to remove that. And square feet per bed and price per square feet we have to reduce, we have to remove those two values as well. Okay, data 3 dot drop of columns equals to, first column I'm going to drop is size, and square feet per bed and price per square feet. So we have created these two columns only to identify if there are any outliers, and as outliers are there, so we have removed those outliers. Now we don't need to have these columns, right? So I have removed them, and axis is equals to 1 and in place is equals to 2. Okay, that is done. Now let's see data 3. Now we are done with the data analysis, right? So let's create a model. So before going to create a model, let's analyze our data one more time. If you see here, observe carefully. So there is a column called location which is having the alphabet. okay, categorical value, and remaining are numerical values. So as I said so many times, the thumb rule for creating machine learning models, before feeding the data, we have to convert this text data into categorical data into numerical values, right? So for that one, we are going to import couple of methods from the sklearn. So let's import them. Okay, from sklearn dot preprocessing. So it is called preprocessing import. Here I am going to import one hot encoder. Okay, coder, and another one is standard scalar. Okay, one hot encoder. Okay, we have this one. Now let's import sklearn dot model selection. We have to split our data set, right? So for that one, I'm just importing this train test split. Okay, now let's import the sklearn dot linear model, which is linear regression. Okay, and so why we are importing one hot encoder is, so what exactly this one hot encoder does is, this one hot encoder is a functionality which is there in sklearn. This method creates the binary values out of this categorical column called location. Okay, so that's why we are importing this one hot encoder method here. And anyway, standard scalar will be used to scale the data for the numerical data set, and train test split to split the train data set and test data set, and finally the linear regression. And as we have one hot encoder and standard scalar and linear regression, we need a pipeline, right? So we have to build this pipeline. So let's import the pipeline model as well. Pipeline method, sklearn dot pipeline import make pipeline method. So we have imported that, and let's import sklearn dot compose import. So we have this one hot encoder, right? So we have to have the make column transformer, so that this one hot encoder will work. Okay, make column transformer. So we have imported this necessary methods from the sklearn. Now let's start with the one hot encoder. Column transformer does equals to make column transformer. So what we are going to do is, we are going to create one hot encoder. Spots output is equals to false. Okay, for which field we are going to apply this one hot encoder is for the location field, which is a categorical column, which will be converted into the binary columns. Okay, figuring this out next, and remainder is equals to pass through. Okay, we are done with this column transformer. Now we have to create for the linear regression. Okay, done. Now we have to create a scalar one, standard scalar. Okay, this is also done. Okay, now we have to fit these three into a pipeline, right? So model, that is our model with a pipeline. Make pipeline. Let's pass these ones, column trans and then scalar. Next, linear regression model. So our model is done. Now we have to split this our data set into training data set and test data set, right? So here we have in a common data set called data 3. So first we have to split the data set into input data set versus output data set. Okay, and data underscore input is equals to data 3 dot drop off columns is equals to except price. Everything should be there in this, right? So price. Okay, and data underscore output is equals to data 3 dot 3 of price. Okay, we have input data set and output data set. So let's split this input data set and output data set in the form of training dataset versus test dataset. Okay, x underscore train, comma, x underscore test, comma, y underscore train, comma, y underscore test equals to train test split. We have to pass the input dataset, data underscore input, data underscore output. Next, test size is equals to by default 0.2. Okay, so 80% of our dataset will become the train dataset and 20% will become our test dataset. Press enter. So we have split the dataset. Now let's split this dataset into model. Okay, model dot fit x underscore train, comma, y underscore train. So see here, it is a pipeline. We have one hot encoder which will convert this location dataset into binary format. Okay, and this remainder is passed through for this one. And again, we have built the standard scaler for the entire numerical values. Finally, this linear regression model. Okay, this is what our model looks like. Okay, our model is done. Now let's model dot score. Let's check the model score. Y underscore train, comma, y underscore test. Model dot score, sorry, x underscore test. So 67.4% our model is working fine. Okay, so our model, this is how we can create a linear regression model which will be predicting the house prices. Okay, let's predict some prices. Okay, input dataset is equals to pd dot data frame. Now columns equals to okay, I'm just going to copy these numbers as it is. Okay, I'll just remove that. Okay, in electronic city with the let me change this value to 1500 square feet. I want a 1500 square feet flat with the 3 bathrooms and 2 balconies. Okay, and let's remove the price. Finally, 2 bedrooms. Let's change it to 3 bedrooms. Okay, columns is equals to, these are the columns, right? One is location, another one is total square feet, another one is bathrooms, and another one is balcony price, balconies, and let's remove the price, number of bedrooms. Okay, now we are done. Let's pass this to our model dot predict of input dataset. So this flat price gonna be 79 lakhs. Okay, change it to 1800 or 2000. So if you see here, the total square feet has been changed from 1500 to 2000. Now our flat price changed to 134 lakhs. So this is how our model is going to predict the house prices with the linear regression model. So now what I'm going to do is I'm going to take it to the next level by creating it as a web application, as you guys have seen in the earlier part of the video. Okay, let's take this model export. Okay, for that one we need pickle as pk and pk dot dump off. What I'm going to dump here, the model. Next, open house prediction model dot pickle with the bright binary access. Okay, I'm just dumped it, and finally I have the data frame as well, right? Okay, now let me export the dataset as well into a new CSV file. I think data 3 is the latest one, I guess, right? So data 3, yeah. So what I'm going to do is data 3 to CSV. So now we have exported our model and we have exported the final dataset as well. Now let's go move on to the create. Now we have exported the model and we have exported the final data as well. Now let's move on to create a web application in Visual Studio. Open folder, Python, house price prediction, select folder. So here we have this clean dataset, new dataset as well, and our model as well. Okay. Here is the pickle file. Let me create a new one, app.py. Okay. First, let's import the necessary libraries. Import pandas as pd, import pickle as pk, and what else we have? I think that's pretty much we have, right? Now import streamlit as well. Import streamlit as st. Okay. What I'm going to do is let me copy a couple of things from here. This one we need, and we need model, right? First, model is equals to pk dot load, and where is our model? Copy path as a read binaries access. So we have imported our model. So let's create a st.header, house Bangalore house prices predictor. Okay. So once we have that, we have to create a drop down, right? Text input. Oh, now we have the clean data. Let's import that first. Data is equals to pd dot read CSV file of this clean data set. We need the locations drop down, right? So we need the list of the locations from this data set. Okay. st dot text text input, choose the location, values will be date of location. Okay. Now st dot let me take it into a new variable called location. Okay. And here again we are going to take the square feet, right? So square feet, st dot number input, enter total square feet. Once we have the square feet, now we have to take the number of bedrooms. Okay. Beds is equals to xt dot number input of enter number of bedrooms. It's going to copy this one, paste it. One for the balconies, one for the bathrooms. Okay, this is for the bathrooms and this is for the balconies. Okay. Yeah, period data frame. So first one here I'm going to take it as location. Next, here it is a square feet. Okay. Next one is bathrooms, right? So bath. So next one is balconies. Next final one is beds. Okay. Our data set is ready. We have to create a button. If st dot button predict price. Okay, if it is being pressed, then what we are going to do is model dot predict of input, and let me call it as output. Okay, and string is equals to output string is equals to price of the house is str of output of 0 into lakhs, right? Okay, this is what going to be the final price. Let me save it and let me run it. pk.load. Okay, it will be pk.load. Open off. Okay, saving it and running it again. Text input. Yeah, should be a select box. Okay, date of location, let me change it to unique values. Okay, delete it, run in a dedicated terminal. Okay, cool. What else? Streamlit run app.py. So here is the final project looks like. Bangalore house prices predictor, and here we have list of the locations. Let's choose Whitefield, and total square feet will be 2000 square feet, and number of bedrooms 3, number of bathrooms 3, and number of balconies 2. Let's predict the price. So the price of the house is 148 lakhs. What if I change just the location? If I change the location from Whitefield to Electronic City, so the price has been changed to 149 lakhs now. Let me increase the total square feet to 2200 here instead of 2000. If you see here, the price of the house has been changed from 148 lakhs to 149 lakhs to 171 lakhs. So this is how our Bangalore house price predictor machine learning model works. So it takes the 5 inputs. One is the location, and another one is the total square feet, and number of bedrooms, number of bathrooms, and number of balconies. Then it will predict the price. If you like the content in this video, please do like this video and subscribe to our channel. Thanks for watching this video.